So today we shall start with finite state machines because in the last class you guys are asking to discuss about finite state machines since it is asked in most of the interviews, right? So we shall discuss about finite state machines today. So can anyone tell me what is a Mealy machine?
Mealy
Am
machine
I
depends
audible?
upon, yes ma'am. Mealy machine depends upon the current input and current state. And on the other
Okay.
hand, Mealy machine only depend upon the current state, not on the input.
Okay. So whiteboard, you can look into it. Now let's draw an Mealy machine for non-overlapping sequence for the following sequence. Okay, let's draw a Mealy machine now. So I'll just show you one example. So let's consider state S naught here, S naught state, and then so since the sequence is like this, when one is given, when one is the input, it will go to the S2, S1 state, right? So we'll be mentioning it as 1 by 0. That is, we'll be mentioning 1 when it completes the sequence, right? This is for non-overlapping. So it'll go to S1 state when 1 is given as the input. And then when 0 is given as the input, it will be going to the S2 state, right? To the S2 state. And then so here S1 will remember 1, S2 will remember 1, 0, and now so here when we give 0, it will be going to the S2 state, right? 0 by 0 will be mentioning it such way, and then when we give 1, this is now we've got the entire sequence, right? That is 1 1 1 0 1. So this is the Mealy machine. For other inputs that is not being used, let us take a different color. So when we get 0 as the input here, it will get back to the same state, that is 0 by 0. And then when we get 1 as input in the S2 state, it will again get back to the same state, that is 1 by 0. And the same way when 0 is given in the input for the S2 state, like in this state, it will go back to the S naught because it will start over again. Because what is the use? Like when we have 1 0, and then again if we get 0, the entire sequence goes wrong, right? So it will go back to the initial state. So it will be 0 by 0 again here. This is a Mealy machine for non-overlapping of 101 sequence, right? So will you guys be able to do it for other sequence? Guys, you there?
Yes, ma'am.
Okay. Will you be able to do for other sequences for non-overlapping? Okay, let us do Mealy machine for overlapping here. This is non-overlapping, right? This is for non-overlapping sequence. Let us do the same Mealy machine for overlapping. 101 for overlapping here. Overlapping. Here we did for non-overlapping. Let's do it for overlapping. So we have same 3 states again. So when we get 1 as the input, like we will be proceeding to the next state, that is S1. So we'll be mentioning it as 1 by 0, right? And then when we get 0 as input, we'll be going to the next state, that is S2. That will be 0 by 1, 0 by 0. Again, the same way, if we see now, since it is not overlapping, see, we can have like one, sorry. Okay, we can have it like this, 1 0 1 0 and 1. This will be one sequence, and again this will be one sequence. So when we will be getting 1 again as 1 as the input, it will go back to the S2 S1 state, right, from here, because it, see, this remembers 1, this remembers 1 0. So next, when we have 1 0 and we want 1 back, and again it can come from 1 0, right? After S1 state, it will again when input 0 is given, it will again come back to S2 state. So we'll get two sequence, like this is for this is for overlapping. And then here, when we get input as 0, it will go back to the initial state. Okay, now let's draw for the sequence that is not being used here. So when we get 0 as input here, it will go back to the same state. Here, when we get 1 as input, it will go back to the same state again. Again, yeah, again this. When we get 0, it will go back to the initial state. So they will be asking you questions like draw an state diagram for given sequence. They might give you any possible sequence, like they will specify if they want it for overlapping or non-overlapping. So if you are able to draw the finite state machine for this, then yeah, it is gonna be great. So let's do the same. You guys know for Moore state machine, or you want me to show for the Moore state machine, guys? Hello. Yes, yes. I'll show you one example each in the Moore state machine as well. So now let's consider a different sequence. Let's consider 0 1 0. Okay. Let's consider 0 1 0 as the sequence. Now, can anyone tell me how many states will be there in the Moore state machine now? In Mealy, we had 3 states, S0, S1, and S2. Now, for this, yes, correct. There will be 4 states in Moore. So when we draw the state diagram for this is, now let us draw for non-overlapping. Non-overlapping, right? Let's draw for non-overlapping. So in Moore, we will be representing as S0 by 0. The representation is different for Moore. So we'll be writing it as S0 by 0. Output will be representing here. So when we get 0 as the input, right, we'll be going to the next state, that will be ES1. So when we get 0 as input, we'll be going to the S1 state. And when we get 1 as the input, that is next one. When we get 1 as the input, we'll be going to the next state, that is S2 state. S2 state. when we get 1 as the input, we are going to the S2 state. That is what here. This S1 state remembers 0. S2 state remembers 0, 1. So next, when we get 0 as input, we will be moving on to the S3 state. When we get 0 again as the input, we'll be moving on to S3 state. So now this, since this is the output, we got 0, 1, 0 our sequence, we'll be mentioning it as 1 here, and then this remembers 0, 1, 0. This is our sequence. Now for all the inputs that is not being used, let us draw the draw. So now when we get 1 here, it'll go back to the same state, right? Again, when we get 0 here, it'll be moving on to the same state. And then here, when we already have 0, 1. And now if we get another, see, if we get 0 here, we'll be moving on to the next state. If we get 1 again, it will become useless, right? So we will be moving on to the initial state again when we get 1 here. And in the S3 state, when we get 1, when instead of 0, if we get 1, we will be again moving back to the initial state. And when we, yeah, and when we get 0 in the S3 state, that is 0, 1, 0, right? And again, this is non-overlapping. So again, 0, 1, 0. So we can go back to the S1 state when we get 0 as the input from S3. So this is for non-overlapping. Now let's do 0, 1, 0 Moore machine for overlapping. This is for overlapping, okay. So now we have same 4 states again. So now when for this is for overlapping sequence, right? So we get this can be the sequence like this 0, 1, 0, and then again 1, 0. So this is one set of sequence and this is another set of 0, 1, 0, right? So this is for the overlapping sequence. So when we get 0 as the input from S1, S0, we will be going to the S2 state. And then S1 remembers only 0. And when we get 1 as the input, right, we will be going to S2. S2 remembers 0 and 1. And when we get 0 as the input, we will be going to S3. And then when we get 1 as the input, we will again go back to the ES2 state because it remembers 0 and 1. See, we need 0 and 1 again. So when we have 1 as the input here, we'll go back to the S2 state. And when we have a 0 as input, right, we will be going to the S1 state. Let's draw for these inputs that are not being used now. So here, when we get 1 as the input, we'll be going back to the same state. when we get, sorry, I forgot to mention here. 1 second. When this is for 1 and this is for 0. And this input is 1. So when we get 0 as input here, it will go back to the same state. And here when we get input as 1, right, in the S2 state, we will be see, when we have 0, 1 and 1 again, like it's useless, right? We'll go back to the initial state again. So here when we get 1, we'll be going back to the initial state. So this is for the overlapping of 0, 1, 0. So in interview, they will be asking you to draw for any sequence. It might be 3-bit sequence or 4-bit also. So you should be able to draw any sequence for 3-bit and 4-bit. You should practice a few state diagrams for like different sequences. I want you guys to try for this like I want you to for and more state machine for overlapping or non-overlapping of I'll mention 4 sequences and you guys try for it. 0, 1, 0, 0, 1, 0, 1. Try for this and then try for 1, 1, 0, 0. Try for 1, 0, 1. Try for this 3 sequences for Mealy and Murray state machines for overlapping as well as non-overlapping. So it will be in practice for you also, because since in every possible interview, they'll be asking you to draw the finite state machine state diagram for particular finite state machine and with overlapping as well as non-overlapping, right? Guys, any doubt on this?
No.
Okay. And tomorrow we shall discuss the code for Mealy machine and Murray state machine. Okay. We shall be discussing tomorrow the particular code for particular state machine tomorrow. Now I'll be sharing a PPT and we'll discuss a few interview questions. So you guys would have come across questions like this in interviews, like how many flip-flops will be used in the first code and how many flip-flops do we use in the second code? Can anyone analyze and tell how many flip-flops will be required in the first code here?
Blocking one flip-flop, non-blocking flip-flops.
Can you repeat again?
And that blocking assignment is there. So
Yes.
one flip-flop is required.
Okay.
For non-blocking, 2 flip-flops.
Yes. Can you explain how this happens? Can anyone explain?
I mean, blocking, we block the statement. That's why A goes to B. Non-blocking
Okay. So
parallelly concurrently blocking. That's why different flip-flops are required.
yes. So here in the first code, A will be assigned to B, and then B will be assigned to C. So it is like it is happening sequential execution is happening one after the another. So A will be stored in B, and then B will be assigned to C, right? So we will need only one flip-flop to store the value of C here in the first code. Whereas in the second code, the parallel execution happens. That is, A will be assigned to B at the same time B will be assigned to C, right? So we will be requiring 2 flip-flops in the case of second code. So they will be giving you a piece of code like this and ask you like how many flip-flops do we require. So this question is like very important in interview because most probably they will be asking about flip-flops itself. Yeah, in any interview, there will be definitely one question on flops. Either they'll ask you to draw waveform of D flip flop, or they will ask you to write code for D flip flop. If not, they will be either asking you to they might even ask you to write draw an counter using flip flop. Like you should be able to do it. So we'll discuss about the questions in the class about D flip flop. We can discuss about drawing a counter using flip flop. They will mainly ask you to use D flip flop there, so we can discuss about it in further class. Can anyone tell me what is a ring oscillator? Is you there?
Yes, yes.
Yes, so I'll explain you. A ring oscillator is nothing but odd number of NOT gates connected one after the another. So you can see this is the ring oscillator. This is how the ring oscillator looks like. So as the sub question they have given us, what would be the frequency of the ring oscillator implemented using 3 NOT gates if each gate has a delay of 2 picoseconds, right? So each gate, so we are using 3 NOT gates here, and each gate has 2 picoseconds of delay. So let's we have to find the frequency of the ring oscillator now. So to find the frequency, we have the formula is 1 by time period, right? Like we have 3 ring oscillators, 3 inverters, and the delay is 2. So we will mention it as 6 times the inverter delay, right? So that is 6 into 2. So we will be getting the following input. You can just make a note of this form. I'll be sending you the PPT. Yes, I'll be sharing you the PPT. So can anyone tell me what will be displayed here? What will be the alpha and beta value that will be displayed here? You can try this code, like what will be the alpha and beta value that will be displayed over here at the end of.
Ma'am, I think alpha will be 3 and beta will be 7.
Okay, can you recheck how you got 3 and 7 again?
Ma'am, first blocking assignment will execute. So alpha value will be 4 minus 1 will be 3. And then non-blocking will start. So then beta
Okay.
value will be 4 plus 3, 7, like that time.
Any other answers, guys?
6, 7, ma'am.
3 and 3.
7.
Answers are 3. Beta alpha value will be, and then beta value will be 3. Here alpha value will be 4 here. Okay, so alpha value see, beta value 3 will be displayed here, and then here you have alpha is equal to alpha minus 1. Again here a blocking assignment is there. So first blocking assignment will be executed, right? So here we have the blocking assignment, that is alpha is equal to alpha minus 1. So we will be getting beta is equal to 3, and again alpha is equal to 3. That will be displayed. You can just try it, try different values and different equations like this, and practice. So practice on Xilinx or EDA playground, and check display the values, or try to display, and so you will understand how it which gets executed first. You will be understanding it, so you guys can practice a different variety of codes like this. So in the next question, can anyone tell me what is wrong here? The code is wrong. Like, can anyone tell me what's wrong with the code?
Ma'am, can you explain the previous question again because your voice is breaking too much?
Okay, sure. Now am I audible?
Yes, now audible. Ma'am.
Okay. Blocking assignment executed in a code. And then we will be going with after that we'll be going with non-blocking assignments. First blocking assignments will be executed in the code, right? So beta is equal to 3, alpha is equal to 4, and then here beta is equal to 3. So the next one here, we have alpha again with a blocking assignment here. So alpha is alpha minus 1. So that is 4 minus 1. So alpha value will be getting it as 3. And then beta is 3 here. That will be displayed. Even before the non-blocking assignments are executed, we'll be getting this, right? This is the value we'll be getting. You can try it with Xilinx and also EDA Playground. I'll be sharing the same code and you can check the corresponding outputs that will be displayed. Shall I move to the next question?
Yes, yes.
Yes, ma'am.
Okay.
Yeah, just
So
wait
what
for.
is wrong?
Yeah, just wait.
D is also the input.
Can you repeat again?
D is also the input, but it's not mentioned in that sentence.
Yes, or in the sensitivity list, D is also an input that's not mentioned. So there will be that will cause an error. You'll not be getting the responding value for E because whenever D value changes, right, we will be E value doesn't change whenever D value changes. So it will give you a completely wrong answer. Then yeah, that is the answer. D is not included in sensitivity list. So we can go through this one aptitude question that will be asked in a verification, like in any interviews, basically. So there is a triangle, and on it there are 3 ants, one in the each corner, and they are free to move any side of the triangle. Mention answer 6 by. Explain how you got 6 by 8.
Ma'am, ant moves in any one of the direction, like it should be in right or left. Let's take right as 1 and left as 0. It
Okay.
means it contains 8 combinations for every ant. It moves in one direction, same direction means it moves in all in left means all are zeros, and if it moves in right means all are ones.
Yes.
Remaining are the collides. That's why 6 by 8.
Okay. Yes. So we will have. Wait, let me share my whiteboard. Guys, is whiteboard visible to you? So we have ants at each corner, right? Each corner, let's consider this an ant or this is an ant here. So of 3 combinations, that is 8. We have 8 combinations, right? So what the probability that ants will face the question? So let's take 2 directions, this clockwise direction and the other one anti-clockwise direction. See, when all the coins move clockwise, right, they will not collide. So all the ants move anti-clockwise, they will not collide. Move clockwise or anti-clockwise will not be colliding. That is ants were not colliding, right? That is when they all move clockwise direction or when they all move anti-clockwise direction. That is the probability of ants not colliding is 2/8. So 2/8. So we can find out the probability of ants colliding will be like 8 minus 2 is 6. That is 6/8. We can do it either two ways. Yeah, I hope you guys understood this this puzzle. So this will be asked in any of the interviews. So make sure you guys go through puzzles like this every day. Okay, guys, that's all for today. Tomorrow we can continue with Murray and Mealy code for different sequences. We can do FSM codes tomorrow. Yeah, thanks for joining.